Hello student, in this particular question a light and inextensible string of length L equals to 20 meter tied between two nails supports a frictionless pulley of weight WP 10 root 2 Newton from which a block of weight WB 10 root 2 Newton is also suspended as shown in the figure. The nails are fixed in a level or distance x equals to 10 root 2 meter apart. Radius of the pulley is 10 centimeter. How much normal reaction per unit of its length does the string apply on the pulley? This is a question based on NLM, and according to the question this total length is given. This total length is 20 meters. So this length is 10 meter. This length is 10 meter. Also, this total distance is given. Total distance here is 10 root 2. So half length will be the 5 root 2. And so what will be the theta here? Theta will be simply sine theta equals to 5 root 2 over 10. So that is coming out to be 1 over root 2, and so theta equals to 45 degree. And by symmetry this angle is also theta, which is 45 degree. So total angle is 90 degree. Now if we take the FBD of the string, a string is like this one, and there is a normal force on the string by the pulley, and a string have some tension force T and T. So we can see that angle we know already, this angle is 45 degree, this angle is 45 degree. So resultant of tension is upward direction, and that is what? That is root 2t, and this balances the normal. So normal is what? Normal on the tension by the pulley is root 2t. And if we apply the FBD of the pulley, then a string applying the same normal force on the pulley upward, and pulley have 10 root 2 weight, and there is also a block connected that also have weight of 10 root 2. So we can see that from here normal is 20 root 2. So from equation 1 and 2 what we can say? We can say that 20 root 2 is simply the root 2t. Root 2 getting cancelled out and t coming out to be what? 20. But we have to mainly calculate the normal. So normal is 20 root 2. Now according to the question, if this one is the pulley and here is contact of the string, similarly here is the contact of the string, so this length is in common contact. This particular length is in common contact. This particular length is in common contact, and normal is acting vertically upward. Normal here acting vertically upward, and value is 20 root 2. So normal per unit length will be what? We have to calculate the normal per unit length by a string on the pulley. This is question, and normal we already calculated 20 root 2, but perpendicular to this normal length is this one. So what is this length? Because according to the question this distance is r, this distance is r, and by geometry this angle is 45 degree. So mainly this length will be r sine 45, which is r by root 2, and also this length is r by root 2. So total length is basically 2r by root 2. So normal per unit length coming out to be 20 root 2, and here this one getting root 2 times. So root 2 r. Root 2 getting cancel out, and normal per unit length we calculated. Normal per unit length we calculated is 20 over r. According to the question, r is 10 centimeter. So 1 over 10 meter. And so that will be equals to 20 over 10. So that is coming out to be 200. Normal per unit length coming out to be 200. So this is our required answer. If we see the options, there is a option given also 200. Option C here correct one. So here there are some geometrical concept as well as equilibrium conditions. Thank you.